Hello everyone, welcome back. Today we'll be doing a new ROM on TryHackMe. Let's get started. First of all, we use rust scan. Dash A is for specifying the target. Dash dash U limit 5000 is for specifying the speed of the scan. And then dash dash whatever you input after the dash dash, those flags are given to the Nmap. So we're telling the Nmap to aggressively scan the ports found and output in text file as JSON all ports.txt file. Press enter and we found two ports open, 22 for SSH and 80 for HTTP. Let's quickly visit that on our web browser. I should have launched the web browser before, my apologies. Okay. Alright, so it says coming soon, please sign up to newsletter to receive updates. Let me turn off my draft reader. Yep, okay. Alright, so we have email address field. Let's just view the source code really. And it says CSS and we have some JavaScript here. So it's getting the element by ID sign up and it's creating a cookie and it's sending a post request and we have the URL here attached with the email parameter and it's getting the app name. So what's app name? Let's quickly see what is app name. Uh, Oops, it's already there. So yeah, so app name is actually the text that we input inside the email address field. All right. So we know a little bit what it's doing. Let's quickly intercept the request in Burp Suite. Let's just try what it's doing. Let's input something like uh, test, submit. Oops. Let me turn on the proxy. We try again. Click on submit, and we see oh, our text that we input is reflected back on the website. 1234 is yep. So it's reflecting back whatever we input in the web application. And we also see that it is built with Node.js. And that's a great info. So we know what it is built upon, what it is implemented upon. So we know that it's using Node.js. Let's intercept this in Burp really quick, just so we know more about what this web application, what it's doing. Let's go to the intercept is on, turn on the proxy, and let's just say testing. We click on submit, and we have the post request here. Let me increase the size. Perfect. Oops. Uh, okay. Yeah, this should be good. Okay. Yeah, so it's appending whatever we insert. Okay. Let's intercept the response to this request. I forgot this. Okay, so we see set cookie on session equals to our cookie is assigned to us. Let's see what it is. It looks like a JSON. Not sure. Let's inspect the element. We should have been assigned a cookie, but we didn't see anything here. Okay. Let's power the request. Nope, no cookies assigned to us. I don't know why. Let's quickly refresh. Okay. Let's try to decode the cookie we just found. So we will use the Burp Suite decoder. I cannot find it. Yeah, there it is. And we decode it as base64. I know it's base64 because I see two equals to sign attached there. It's usually base64. So base64 and we have we see that our input is attached in the cookie. Okay, so we know that it's using Node.js and a cookie is assigned to us, and in that cookie, our whatever we input is in the cookie. So yeah, we see the cookie has been assigned to us now. It's the same cookie. So if you decode this, you will get email test, if I'm right. Yep, email testing. So what if we input our payload of Node.js to get reverse shell in place of testing? We should get a reverse shell. So let's just try something simple. We'll say email TechMafia and we encoded the base64, copy this, paste it, and we should see TechMafia on the website. Yep, so we know that it's fetching the data from the cookie. So this cookie is actually uh, kind of, if you decode this, we see that it is email tech mafia and this is serialized data. So the cookie we see ey starting with ey ending with equals to sign. This is the serialized data, and this is getting unserialized and then displayed on the website, if I'm right. So we can quickly search up Node.js deserialization attacks because the cookie is getting deserialized and then displayed on the website. And we quickly see interesting results pop up. Exploiting Node.js deserialization, and we see some more results. We have Node.js node serialized remote code execution and a couple of more results. Let's quickly see that script that we found of RCE. There's a payload and URL. So as the script query, someone will try to copy this and run it. So we will do that. Let's quickly copy this. Instead, I'll just view the raw version and then download it. Let's run it. So Python 3, and it's a syntax error, probably a Python 2. Yep. It says, oops. Let's quickly view the source code of this file so we know what it's doing. And of course, we need to change the URL first. Let's change the URL. Okay. And that is our payload. And we need to change our IP and port in the reverse shell. So it's a port 80 and my TryHackMe IP. Let's launch the reverse netcat listener. And I guess that's it. I'll save it if I'm right. Let me remove this. I guess it's not necessary. Not really sure. Okay, let's just try it. So it's going to this. It's making a GET request to the URL using the cookies, and it just prints the response. If the request is successful, let's try running it. We don't get any response back, and it's not responding at all. So what I'll do at this point is I'll try to intercept the request in Burp Suite. So let's go to proxy tab, options, and let's uh, oh god, wait. Yeah, let's add a proxy listener on 8081, and we'll redirect the request to the website. That is this and redirect to port 80. Okay, so we can catch the request being made to our localhost on port 8081. So in Python script, we will input our localhost URL with 8081 port. Let's do that so that we can intercept the requests. I guess that's it. Let's save it and um, what am I doing? Yep. And we see the intercepted requests. It's this is the cookie. Let's decode it. Okay, so it's using this payload to get the reverse shell. So the log executing the reverse shell here, and yeah, that's it. It's a function, I guess. Yeah, it's a function. Mhm. I just intercepted the response to the request, and I do not see any response back. So that is why this script was not responding. I'll turn off the intercept. No, we don't get any response back. Even our IP is correct. Okay. Let's just try another way. Let's leave it. So there was our script keyway. And let's just see this article. Okay, so I'm not gonna read this all. You should read it. I'm just gonna copy the payload. See, it's dot execute, so it's executing the ls command. I'll copy this. I'll create a new file named serialized dot. I guess it's JS maybe. Yeah, paste it, and instead of ls, wait, we'll execute ls command. Oops. Node serialized.js. We have our payload right here. And let's copy this. So if we go on to creating the payload of this actually won't work because uh, our request, whatever input here is shown on the website, but if we execute ls command, it won't be shown because uh, only the content that we have typed out is being shown on the website. But if we execute ls command, it's been executed in the back end, not in the front end. So we will not be able to see it. So that is why we, instead of ls command, we'll try something else, like pinging back our machine. We can, we can catch the request. We can catch the ICMP packets that are made to us. So let's quickly do it. ICMP packets are the ping packets. If someone is pinging us, it means that he's sending ICMP packets. So you see right here, it's saying ICMP underscore sequence. So if you ping someone, then you are sending the ICMP packets to them. So we are capturing the ICMP packets. So if someone pings us, then you see a response right here. So we will create a payload that will ping back our machine. Let's edit. And let's say ping dash C one, dash C is for count one, and then our IP. So it will send one ping request to our IP. Let's quickly create the payload, and we have the payload here. It's not the payload, it's a serialized string, you can say. Oops, not here. We first need to encode it. Let me copy this. Let's go to the burp decoder and let's paste it inside the email right here. So let's first basically for encode it and let's paste it here. We refresh the page and we do not see any response back. Pretty odd, right? And that is because our function is not invoking. So we should invoke it. And to invoke it, we need to append parentheses at the last. So it will self-invoke the function, and the function will run, and our code will run of ping. I just said that in easy words, uh, not too many technical terms. Let's paste it here and refresh the page, and we should see a response back. Yep, we do. All right, pretty nice. We have the code execution. So let's try getting a reverse shell back quickly. Let's edit this, and let's quickly. So let's change the command execution to netcat in order to get a reverse shell back. We can try Python, but it's really long, so I'll go for the netcat one, as it's just one line. Okay, so let's change the IP to my TryHackMe IP, and I'll say the port to be port 80. Okay, let's create our serialized string. There it is. I'll copy it and let's paste it here. Also, we want the function to self-invoke, so we'll append parentheses here, opening and closing. Perfect. Copy the payload, paste it in the cookie section, refresh the page, and we should get a shellback, and we do. Okay, perfect. So let's see which Python. We have Python 3. Let's import a shell quickly. Export term equals to xterm so that we can clear the shell. Okay, so we can quickly see the source code of the application. So here you can see that okay, so it has started, then with a function, and if the request URL is homepage and it's being a GET request, then it will go on to another if statement that will check if the cookie is in the request. So if the cookie is in the request, then it will assign a new variable named cookie, and it will be assigned the value of request.headers.cookie.split. So it will split the cookie at the equals to sign. You can let's see it in the buff suite for better understanding. I'll intercept the request. So yeah, we have the cookie here, and you can see session equals to this. So it will fetch the content. It will split the session and the cookie with the equals to sign. Okay, so it if cookie 0 equals to session, so if the first value is a session, yeah, this one, so it will go on to fetch the cookie one means it will take the cookie that starts with ey and ends with the equals to sign most of the times. So it will take that and convert it to string. Then it will unserialize it because it's a serialized object. Then it will go on. I'm sorry. And then there are some access filters, I guess. Then else statement says replace with the coming soon. Not sure of this, what it is. Then we have else if statement that says if a URL includes the email parameter, question mark email, then yeah, if includes the email parameter and the method of the request as post, then it will say posted email. Yeah, so if we submit something, then it will be a post request. So it will say posted email, and a cookie will be assigned to us because there's no cookie at first. The first time you visit the website, there's no cookie assigned to you because you have not submitted anything. So once you submit something, cookie will be assigned to you. Okay, so let's see what we can enumerate. We don't see anything. So let's see if there's something in here. Nothing. We have backups folder here. Let's see if there's any backup. And nope. That's just the default content. So we have a dial-in users home folder here, and we have a user flag here, and nothing interesting. So we can see the users in this machine with RCE password file. We have dial-in and no other user. Okay, so let's see what commands we can execute as sudo or as root. So you can see the -l meaning in the manual of sudo, and -l means if no command is specified as the allowed. Yeah, so it will list the allowed commands you can execute as root. Perfect. So let's enter, and we see that we can execute user bin npm. So npm is a binary. We can execute it as root. Let's see what it is. A manual of npm. We have JavaScript package manager. So if it's a JavaScript package manager, uh, for Node JavaScript. Okay, so it's related to Node. It says you probably got npm because you want to install stuff. So it installs some stuff, and it's related to Node.js. All right, and yeah. Okay, so we know that it's related to Node.js. We can quickly search this up on GTF bins, because if I see a binary, then I usually search it up on GTF bins. Let me turn off by proxy, and okay, npm, and yeah, we can execute it as sudo. So I'll click on sudo, and here you see this command make temp dash d. So what this does is it creates a temporary folder for us, or we can say temporary directory. So it will create temporary directory. So you can see the output of this. So we'll assign it tf. So if you do echo tf, you will see that the value has been assigned to it. So it's just a location of the temporary file created, you can say. Next command is this. Let's just copy paste this. We know that gonna execute bin sh to get into the shell. Then copy this thing, that is sudo npm. I'll copy that dash c, and I'll say sudo np user bin npm, and then paste this, press enter, and we should get a shell. Oh, okay, yeah, there is. We are root in the machine. Usual stuff. Do python 3 dash import pty.spawn. Nothing new here. Oops, I can't type today. Sorry. Okay. Yeah, so we are root on the machine. That's the end of this story. So I hope this video helped you, and thanks for watching. See you next time.